Okay, I think we're ready now. So what I came here to talk to you about today is really more of a cultural talk than a technological talk, just as Blarim says, and I'm going to talk to you today about how to build a monitoring democracy in the companies that you work for. Before I start, I'll tell you a bit about myself. I've been a software developer for more than 15 years. I've been filling out various roles like a developer, a DBA, and in most recent years I've been doing DevOps work for a few companies. And throughout my entire career, I've always developed services with looking at them through the lens of monitoring, which meant that I always thought about how I'm going to troubleshoot issues that arise either in the middle of the day or in the middle of the night, and I thought about creating visibility for these services so issues could be troubleshoot more efficiently, and that's why I really like looking at the changes and evolvements of this discipline in technology, how we monitor stuff more efficiently, and all of the different tools that we can use to achieve that. I work for Soluto, which is an Israeli company serving as an R&D center for a greater American company called Asurion, and we build a web and mobile experience that users can use to troubleshoot and get more benefits out of their technological products that they use in their day-to-day lives. We allow them to talk with experts and then get all of the support that they need in a very technological and sophisticated manner. And since we have more than 300 million paying users and we want them to get the best experience that they can get, monitoring plays a very key role in achieving that goal. So now that I've set the stage and explained why monitoring is dear to me and the company I work for, I want to ask you a few questions. And the first one is, should you monitor everything that you deploy into production? And I'm not sure if you're thinking yes or no, but I came to think that this question is not as straightforward and simple as it first seems, because everything is a very relative terms. You can go with the classics and just monitor the CPU or memory for every server you have in production, but what if this server is using a service that is very sensitive to latency? What if it queries a queue that can accumulate messages? All of these different aspects should be monitored. And what we found in Soluto is that it's better to leave these decisions to the people that are actually building the applications you deploy. If you let people make the stuff that is really critical and really important to them shine and be very visible, you get to troubleshoot issues a lot faster. And I'm going to show a set of tools that allows for achieving exactly that in this talk. The second question I want to ask you is, can alerts suck less? And I'm happy you're nodding, because I didn't came here to show you how to be overjoyed whenever an alert triggers your pager, but I am talking about a certain kind of alerts which suck more than others. Alerts like the kind that pops 100 times a day and become white noise, concealing actual issues that harm users. Other alerts have no actionable task that you can carry out when you want to resolve them, and they leave you waiting for a transient issue to resolve, or leave you acting as an intermediary to another authority that can resolve the alert. And this could be very frustrating situations that create alert fatigue and can harm the way we troubleshoot our production environments. And the last question is, who carries the pager in the companies that you work for? Because I'm sure you're all familiar with the traditional knowledge in the traditional model that creates a tier of support engineers that act as a buffer for every alert that comes to the organization. And then once these engineers go through a set of mechanical steps, only then they will escalate the issue to a higher authority, leaving a higher resolution time and more frustration with your users. And we at Soluto ask ourselves this exact question: who carries the pager? And I want to take you through the different iterations and different solutions that we had when we tried to solve this issue. And I'm going to start with the time when Soluto was a very young company and it had very few developers. And all it could do at the same time is task one person with the entire stack of monitoring all of our production. And I see Max nodding, so I'm assuming he's familiar with this pattern. Young companies tend to do that, and it's an okay thing to do when you're low on resources, but as the company grows, that guy who is writing all of the monitoring rules, receiving all of these alerts firsthand, and trying to troubleshoot all of them, or finding the appropriate person that can troubleshoot them, that guy usually finds that he sleeps less and less every night, that his sanity starts to deteriorate, and he contemplates a lot about the decision that led him to this point in life. And as our company started growing, we realized that we couldn't put such a burden on one person and tried a more sophisticated model. And the first model we tried is a rotating on-call duty, which gave every developer the ability to hold the pager for a week, wake up in the middle of the night. It gave the guy from the previous slide some much needed rest, and it also allowed every developer to try to mitigate production issues himself or herself, which is a very important skill set in today's workforce, and also get acquainted with other aspects of the product they wouldn't get acquainted in their day-to-day jobs. But the company kept growing, and developers felt that there are still intermediaries that have to defer the alerts to another authority. And again, this made MTTR, the time we take to recover, a lot longer, and we wanted to solve this thing from the root. And as the company got splitted into teams, each team interacting with other aspects of the product, we further evolved into a model in which every team gets its own on-call duty. And that brought us to a nice sweet spot in which all of the alerts are routed to the appropriate team that can resolve and recover from the issues that come to their specific services. But this brought a very interesting challenge. Throughout all of this evolution, we found an interesting, unexpected challenge happening, and it was a cultural shift. And what I mean is that we were changing the culture from one where services were developed in one silo and operated in another, to one where developers got the entire ownership of the product, meaning they had to design it, develop it, deploy it into production themselves, and the missing part that we were trying to achieve is let them monitor it as well. But since we were acquainted with the way configuration of modern monitoring tools is happening right now, we knew it was a difficult task, and we knew that if we just present them with an open source tool or some kind of solution that is able to monitor the production environments and won't make it something as simple as possible, they would just scratch monitoring off their list, assume that the services are running fine, and say that monitoring is not something that is really critical to them. So for that matter, it was really important to us to come up with a very simple and very straightforward solution any team could use and get the most out of the monitoring potential that we wanted to offer them as the operating team of the company. So when we were looking for the technology that will enable the culture we were striving for, we started out with setting a few key points that we wanted to achieve before starting actually writing code and developing stuff. And the first solution that was really critical for us is that it would be self-service, and any engineer would be able to interact with it without having to defer it to another silo or get guidance from someone or have a gated authority blocking these changes. The second thing that we wanted was scalability, and not only in the form of the amount of hosts or services that it can monitor, because that's obvious. We also wanted the ability to get as much flexibility as we can in a production environment, meaning that the final solution would be able to interact with any language or a cloud provider or anything that we decided was good enough to run our production workload. And the third requirement was that the solutions would be open source and have a wide community, letting us know that we are solving the question in the same way a lot of other companies solved it in the near past, and also gave us the knowledge that we would have transparency into the roadmaps of these products, and let us be sure that in case we have an issue, we can just submit it to the maintainers of these projects and even contribute features of ourselves in case we have the time and resources to do so. And this is the solution we came up with. A few of these components are probably familiar to you because you're here, or also from the talk that Max gave. And I gave him a lot of thanks because he managed to explain the main part of Icinga and Puppet very well. And this is something I couldn't have done as good as him. But since it's still a big diagram and has a few moving parts in it, I want to go through it layer by layer and start with the bottom layer, which is where we keep all of the data that our production environment is producing. And the reason we even need a data source for our monitoring is because we don't want to actually actively monitor everything that we're running in production. We want to give our developers the power to decide which data is relevant to the stuff that they want to alert for. And if we let them instrument their code in a way that writes all of the data to a centralized piece of data source, they can create queries on that data source and get the relevant alerts that they want. So I'll start talking about the different data sources that we are using. The first one is Prometheus, which is a very popular time series database that allows me to send a lot of data points, that allows, Prometheus scrapes a lot of data points from the stuff we're running in production. And then all of these data points can be plotted into nice nifty graphs like the one we see here. In the graph that I show here in the example, I'm using it to query the time builds are waiting in my CI server. And in case that amount of time goes up and users are...
I'm sorry, could you stay on this side?
I'm killing your camera vibes. I'm sorry, I will stay here. I'll be a good boy. So now that I'm stationary, I'm trying to alert whenever builds are accumulated in my CI server, and whenever users are experiencing frustration because their builds are not being picked up, I get an alert, and then I can see what is being stuck in the server that is currently crying. Another data source we are using is Elasticsearch, which is a cluster I'm using to send all of my logs to, and it gives me more verbosity over the previous data source that I've shown. I can look at abnormal amount of logs like the one that is circled here, but I can also make more intricate queries that will tell me if these logs contain certain texts that should be ignored, or maybe other texts that are more critical and should be alerted for in a lower threshold. And using all of these data sources combined gives me a very good bird's eye view of my current production environment. But the biggest advantage that we found when we were crafting this solution is that we can monitor and use any data source that we choose. We're also storing a lot of data in MySQL servers and SQL servers, and we can query those very flexibly. We are also using Graphite for a lot of years. It was the previous popular time series database used for this solution, for this matter. But as our services started onboarding Kubernetes and Prometheus became a very obvious choice, we were able to seamlessly migrate from Graphite to Prometheus. And the reason this migration was so easy is because of Icinga, which is the reason we're all huddled here today. And Icinga has a lot of plugins, and it's a very powerful piece of monitoring solution that provided us with plugins for each one of the use cases that I've shown before. Most of them were open source and didn't require too much work on our part. We just had to download them from GitHub, and voila, the work was already done for us. But as I said before, Icinga is a complicated product, and it's hard to allow every developer to interact with Icinga and learn all of the knowledge that is needed in order to operate it. And that's where Puppet really saved us. I'm guessing the guys that develop Icinga knew this as well. And the Puppet module developed by the Icinga developers allows us to store all of the monitoring rules that we want developers to write in the Hira database Max talked about. We can save it in JSON objects, which are very familiar and very easy to use for every developer in the company. And I did want to show one example of how easy it is for a developer to add another host to the Puppet repository that we're using. When a developer wants to deploy a new host, all she has to do is create this JSON object. In this case, I call it the generic API, but it's any name she can think of. We import it into a template very similar to the stuff that Max showed us that gives the developer a lot of checks out of the box, like the expiry of the SSL certificate. Since this specific service is a web role and exposed to the internet, it also queries the is alive endpoint for that current host. And whenever a unique check is needed to be added, it can be added as a variable to that host. And in this example, query Prometheus in a specific way. This specific Prometheus check is designed for a service that is planned to be very verbose and receive a lot of traffic. So I'm querying Prometheus to know that I have at least 800 requests in the last 5 minutes, because I know that if I dip below it, something in the pipeline must be broken, and I should alert the developers, or the developers should get an alert that something is wrong. So now we can take a look at the engine of Icinga managed by Puppet, and what are the advantages we are getting from using it. The first one is that we get monitoring as code, which is a very powerful ability. It allows me to get revision control for everything changing in my monitoring infrastructure. It allows developers to ask for reviews whenever they make a complex change. And it also allowed us to use automated tests in the same way that Max showed. We have a staging environment. In our example, the staging setup is actually a Docker container pre-baked to be as close as possible to our production environment, and only the diff and the increments that are available every time, that are inserted every time, are being tested against to provide for faster cycles of development. We're using Icinga's modular domain-specific language to create a lot of templates and apply services anywhere we can. And we are also using dependencies to make sure that if a data source is not available, the alerts that depend upon it won't fire and cause white noise. And this keeps our code very lean and simple. And the best thing we found about Icinga is that we can use it to monitor anything that we can think of. And in a few slides from now, I'm going to show some untraditional and, I don't know, unique things that we've done when we wanted to monitor what we run in production. But before I go to more complex scenarios, I want to top off the diagram with its top layer, which is PagerDuty. We're using PagerDuty as a way to route the alerts that fire from Icinga to the actual endpoints that the developers are listening to. PagerDuty is a very robust and simple solution, and I don't need to say too much about it. Suffice to say that it integrates with Slack, mobile applications, and phone calls and emails. So pretty much any notification that is comfortable for the developer to be notified by is in his disposal, and every developer can tweak it as he or she wants. And now that we know the entire diagram, let's see if we set out and achieved all of the requirements that we were trying to achieve. The first requirement was that the solution would be self-service, and we noticed that in Soluto, every developer manages to interact with this solution and write whatever he wants without too much help from the DevOps team. All they can consult the documentation and many references that are already in the Puppet repository, and it makes for a very steady stream flow of monitoring rules being written. This solution is incredibly scalable. We started out as a company that specialized in .NET and was running on a certain platform on Azure. Since then, we branched out to work on all 3 major cloud profiles. We're running on a few other niche services, and our stack has evolved to include Node.js, Go, Ruby, Python, and a few other small languages. And every component that we integrated into our system has been able to be monitored very well using the stack that I've shown before. And apart from PagerDuty, every component that I've showed you here is open source, and there's a very wide community. We found that we made good bets with the product that we've chosen for this solution, but we also feel that we can change them whenever we feel that a new contender has arrived, like with the example of Graphite and Prometheus. A few statistics about the repository in which we're holding the Puppet code. We've been running this solution for more than 1,000 days, and in those days, more than 6,000 commits were written into it. We get about 6 commits a day, which shows us that it's growing linearly and in proportion with the new things deployed into our production environment. And the most peculiar figure to me was that more than 75 people have contributed code into the repository, and what made it intriguing is that we have less than 75 developers in Soluto. So I was really curious to understand who are the people that are not working as developers, but still find time to put code into GitHub. And that piqued my interest and led me to snoop around and look for the commits that are being committed from these people. And it led me down an interesting path. It led me to a talk I had with one of the product managers in our company. And she told me about the time where her team was tasked with changing the onboarding process of our product. And because the onboarding process is a very sensitive and delicate part of the first impression we give our users, we wanted to make sure that changes done to the onboarding process were not harming the users using it. And in the picture, you can see the analytics platform that we're using to monitor this kind of stuff. And that product manager found herself coming to work every day, sitting in front of the computer, logging into the analytics platform. In our case, it's called Mixpanel. It's a cute SaaS. And just manually checking that the number of users currently finishing onboarding is similar to the last week and the week before that. And she felt it was a very inefficient process, and there must be a way working in a technological company to make this more streamlined and automatic. So she consulted one of the developers that told her, sure, we can just write a plugin for Icinga that would query Mixpanel and monitor this as we monitor everything else in our system. And they did exactly that and created a plugin that we open sourced, and you can find in the list of references that I attached at the end of the slide deck. But basically, it's another JSON object that's running a different check command, and this time, instead of querying Prometheus or Elasticsearch, I'm querying the analytics platform, giving it a few values that tells Icinga what it needs to monitor. And in case we dip below a certain percentage of users that we feel should be the normal number of users onboarding, we just alert and get peace of mind with the knowledge that we have programmatic checks that monitor the business end of our product directly. Well, once we've seen these kind of use cases are being taken in Soluto, we realized that part of our job was successful because we gave a lot of liberty and a lot of ownership to developers, and they're actually using the monitoring platform to create very creative and very intricate ways of looking into production. But we also realized that the company is big enough for us. We also realized that the company became big enough for us to not notice when a developer is taking a wrong turn or doing something that we don't feel comfortable with as a big company. And we knew that there was time to collect ourselves again and install some governance and let us know that we have guardrails over the stuff that the developers are doing into their day-to-day lives. And if they want to take a wrong turn, it would be very hard for them to do so without us knowing and without getting notified about it. So the first thing we've done when we wanted to govern the company in that way is we wanted to track costs, because a lot of things deployed into production every day means that a lot of money is being added to the public cloud that we are using, and sometimes these changes are very predictable and they reflect the amount of money the team was prepared to spend on a certain feature, but sometimes it can be a very surprising thing. You can look at the budget at the end of the day and realize that it's a lot higher than what you expected. So what we've done is we've created a scraper that goes over all of the resources that we have in the cloud, pour it into a MySQL database, and again, because Icinga can integrate well with such a database, we've just created checks for every team listed in Icinga, reflecting the current cost of the cloud resources it's using, a warning threshold and a critical threshold that are pretty far from what they are using right now, and allow them to update this number whenever they plan on expanding and accounted for that capacity, but also leave them the ability to be triggered by an alert whenever whenever a drastic change takes part. But this was a very long endeavor, and it required us to create a lot of code that would take this and make this a reality. And once we finished that and got to work on a few other interesting aspects of governance, we find out that we actually spun a very nice spider web that caused all of the developers to write their entire production workload as code in the Puppet repository, and therefore it reflects the stuff that we want to monitor. So when we set out for our next assignment, which was governing the security posture of the company, we realized we don't need to write anything that will actually look at production and monitor it actively. All we had to do is apply a check to the hosts that are currently running in Icinga, and that check would, out of the box, monitor security for every team that is currently needs that kind of review. So in this example, this is the security services that we have applied to every service in Icinga, exposing an HTTP endpoint to the outside world, because we thought that was the most critical part we want to deal with first. And all we had to do is write a few checks that, in this case, check for web server leaking sensitive details, or a server that is using weak ciphers and could be easy to hack. And the minute we applied that, we had a way to notify developers whenever they are suffering from these kind of issues. And we could also get a centralized dashboard that we can show stakeholders and let them know what is the current general security posture of the entire company. Another thing that we found is, as I was saying before, we were onboarding Kubernetes, and our cluster right now is pretty crowded and has a lot of services in it. And this presented us with new problems that we weren't accustomed to it, because Kubernetes is a multi-tenant architecture, and it requires all of the teams to play nicely and not step on each other's toes. And we started to have issues with teams that were expanding and consuming the entire resources in the cluster. All of the teams were separated into different namespaces, but without quotas, there was nothing that would keep them at bay whenever they wanted to just gobble up all of the resources. And again, we wanted to install quotas, we wanted to govern the developers, but we wanted to keep what we had alive and keep the ownership and power that we gave to the developers, so they won't feel like something is blocking them without having clear visibility to what it is. And again, we found that Icinga was a really good solution to tackle that, because once we programmatically compared all of the stuff that we have in Kubernetes with all of the stuff that we have in Icinga, and added the Kubernetes namespace variable to every service monitored by Icinga, we got a reflection of the quota for each service, for each team attached to the service currently running in Kubernetes. And now when teams are getting closer to consuming their quota, they get an alert, they get a run book that explains to them how to overcome this alert, how to check for issues with the current code that is doing the problem, and even temporarily raising the quota, so they can get through the night or the time where an emergency happens without impairing their production environment. And all of that is achieved without harming other teams. We're very pleased with the way this solution is serving us, but we still feel there's a lot of stuff that we want to accomplish and improve. The first thing is visibility. We currently give the developers the ability to open a new branch, make sure the tests are green when they write new code, but after they merge the branch into production, Puppet pulls the configurations asynchronously, and the developer has no visibility to when his changes were actually assimilated into Icinga. I'm hoping the next talk about the HashiCorp stack could help, because I feel Terraform is more well equipped to handle these things, but I've been looking at the module and I don't think it's mature enough. We do want to deploy a more straightforward solution, like a Slack notification that would be sent when the configuration is applied, but we're not completely there yet. We also want tighter coupling with the monitoring rules and the logic the code is currently employing, because what we have right now is one repository holding all of the each microservice that we're deploying in production, and we have another repository that holds all of the monitoring rules for every service, and this disparity leads to drifting between the monitoring and the logic, and we do want to make these things more tightly coupled, so a pull request or a feature branch can hold the change in logic and monitoring in the same place. I'm going to take you back to where we started and ask the 3 questions that I've asked in the beginning. The first one was, should we monitor everything? And the way we see it in Soluto, everything is not something that is easy to define, so it's better to concentrate an effort on the parts that matter instead of trying to tick boxes and do what someone else defined as monitoring. alerts can suck less, and they suck a lot less for us. We've been getting a lot less alerts in the last couple of years, during the couple of years this thing has been traveling with us, and the time to recover from alerts has decreased drastically. And regarding to who carries the pager, in Soluto, anyone that is writing code has to carry a pager, and we found out that it gives us a lot of benefits, and people actually enjoy this thing. Any questions?
How do you manage the repositories? Do all the developers deploy to the same one, or are there different ones? And,
do you mean the code repositories, or?
I'm sorry, can you ask again? What was the question?
I'm asking if you're referring to the monitoring repositories or the actual code.
Yes, exactly. Do the developers deploy to different repositories, and do they deploy to different monitoring repositories?
Yeah,
or how do you handle the repository management in general?
It's a separate repository. In Soluto, we have a microservice architecture, which means which we chose to manage in a way that every service gets its own repository, and the monitoring is defined in a separate repository. That's a mono repo for the entire Puppet configuration.
Okay, thank you.
For sure. Any other questions? Yes.
You said everybody carrying a pager can configure how they're alerted.
Yeah.
So you don't have like just one way that's default, so everybody just decides that 100% for themselves? No,
that's why we liked pager duty. We like to hold our developers accountable and let them know that we give them complete freedom. If a critical alert is triggered in the middle of the night and the duty doesn't pick it up, it would escalate, and it will still eventually get to a company-wide duty. These alerts are very rare. These events are very rare that something has to escalate so deep down the line. But we had issues when people misunderstood the way notifications work and only configured it to Slack. And when we found out that's the case, we gave them a talk and explained to them that it's their decision to do so, but they have to know that they still have to wake up.
When you use both, like Icinga and PagerDuty for the notifications, what do you use for the SLA reportings, for example? Icinga or PagerDuty?
SLA reporting is an interesting question. We have some services that are tested against their availability, but it's not a wide thing. It's not a, how do you say it? It's not something that we practice company-wide. I do think that our SLA is being defined by the mother company, because as I said, we are a subsidiary. So whenever they detect an issue, it means that we resolved it too late, and that's when our SLA begins to deteriorate. So I can say safely that 99% of the alert that we receive, we handle them proactively, and they don't seep all the way to the actual partners using our products. But if that happens, the SLA is calculated by the business factor, which lies in a different company. Any more questions?
Do we have any more questions? Maybe one more? No questions. Thank you very much, Yaron.
Thank you.